Hey everyone, this is a video to help you write the equation of your timeline graph. So you should have with you a copy of this graph. We'll do this one together. So this is the example that I'll go through in the notes, and then you will go ahead and write your own. So for this, you need this graph. You can find that on Canvas. It should be also linked in this assignment. And if you have any kind of colored pens, pencils, highlighters, you know that those are always good. You know, I'll be using all my color coding, so feel free to have those things nearby as well. All right, let me share my screen here. Oh, and a ruler. If you have a ruler, that's helpful too. Okay. All right, so first thing I'm gonna have you do, so the paper that you have printed or it's uploaded to your Chromebook is this. And there's a couple things I would like for you to add to it. I feel for you guys with the videos, and I know that those of you who have given me feedback appreciate being able to pause, rewind, fast forward. So please review any of this as needed, and of course, reach out with any questions. But I'm gonna have you add a few things to your paper. Feel free to pause this and add these things as well. The first thing is a title, and I've called this linear piecewise functions. Linear because everything is in a straight line. Piecewise because it's in pieces. Now, not every piecewise function has to be linear. In fact, later on in this unit, we're gonna swap out some linear pieces and add in some other ones like exponentials, periodics, quadratics, any of those types, but we're all gonna start with lines just to make sure we're all on the same page. And so this box down here will be where we keep for reference different ways to write the equation of a line. So keep that there. The other thing that I've done at the top here is every piece of this function, and by a piece, I mean, can kind of just point them out, right? So one little steady strip right there, and then there's a decline, and then we're going up from there, then steady across and up again. So it's helpful. One thing that it's helpful for me as I'm, I guess, reading graphs is think about it like reading a book. You're reading from left to right. So I remember there was a point where I'm always like, well, how do you know if you're going down or if you're going up? Because it depends on where you start. So if you think about reading a line from left to right, you can also tell things like its slope. So for example, in section 2, you can tell that line, if you read it from left to right, it's going down. So we have a negative slope here. In fact, I'm gonna write a little negative sign there. Okay. And then once I'm here and I go from left to right, I'm going up. So section 3 is gonna have a positive slope. I'm going straight across. I'll just say that, give it a steady slope all the way across. That's actually a slope of 0 when it has no tilt at all and it's just a horizontal line. And then when I'm going from here to here on section 5, that's a positive as well. So it's just helpful to keep in mind as you're going, because we are going to be talking about the slope of each one of these individual sections. All right, so let's go ahead and talk about how to write the equations of these lines. So I do have 2 different horizontal sections here, and when I have a horizontal line, the equation of that line is pretty simply just y equals, and then whatever number your little section of the line comes and hits the y-axis. Okay, make sure you also label your x and your y-axis here. So if I went up by ones, this would be 1, 2, 3, 4. Just put a couple numbers in there. And if I'm going down here, that would be -2, -4. So the equation of this one in section 1 is y equals 4. We're going to write the equations down below here. Just for now, we're going to keep a kind of like a review with the different forms of the lines in here. So I'm going to keep that as just y equals, and then how about we say whatever number it hits the y-axis. So similarly, if you had a vertical line, now I don't have any vertical lines in my graph. That might be kind of weird. I don't know how we would think of that in terms of time. But if I did have a vertical line instead of a y equals, it would be x equals, and then the number where that line, let's say for example, I had one over here, where that line hit the x-axis. So similar, except a vertical line has the equation x equals. All right, let's move on to the two that we're going to be using most of the time here when we write our lines, because most lines have some kind of a slope to them, right? If they have no slope, they're going to be either the horizontal or the vertical line. Actually, the slope is undefined. This one is 0, but we'll get to that at some point. And then if it does have a slope, and you can also pick out a point. So for example, let's say that I was looking at section number 2 here. Definitely has a slope. And if I were to pick out one of the points on that line, I'm just going to use that one because it's there. I'm going to call that one, if I were to label the coordinates of the point, that would be 1 and 1, 2, 3, 4. So it would have the coordinates 1, 4, that point there. So if you have a slope and you have a point, you can use this equation. And the equation is y equals m, which stands for slope, x minus x1 plus y1. Okay, let me talk about what those pieces mean there. So m stands for slope, and slope, probably as you remember it, I usually think of slope as rise over run. So I'm just going to write underneath there, that's rise over run. There's a formula for slope as well, but it's pretty easy to count when we have a graph like this. So I'm going to keep it as rise over run and use it like that. And then the other thing that we need on this equation is a point. And the point is represented by x1, y1. Okay, so if we were going back and we were coming up with the equation of this particular section, we would need a slope, which we'll do when we get to that section. And we need a point, which we have, and so we can use point slope form. Okay, so this is the one I feel like we're going to use most often when it comes to this particular, example. But another one you can use, and I would say an equation that a lot of people kind of quote, it's one that's, I don't know, dare we say like famous, is y equals mx plus b. Okay, and the difference here is not with the slope, because we still have a slope on this one. The difference is this right here, and the b represents the y-intercept. Okay, so if you have a line, and it's harder to see on this one because actually none of our lines except for this one run through and touch the y-axis here, but if you did have a line that went through the y-axis, and so you had a slope and you had a y-intercept, this one would be a better one to use. So they're interchangeable. It just depends on what pieces you have. So I wanted to point that out, and that specifically for these examples, we're mostly going to be using point slope. So when we come back, I'm going to pause it real quick, but when we come back, we're going to write the equations for each one of these sections. All right, so let's start with section 1. And section 1 is just that little piece right here. In my timeline, it was between grade 0, which in my mind I suppose is kindergarten, and goes up until 1st grade. And that was pretty high, pretty steady. And since that's a horizontal line and it crosses the y-axis at 4, it has the equation y equals 4. Okay, pretty simple. So that's the first one. Now, the second one, or the second piece, I'll call it, goes from here to here. Now, in terms of my timeline, that's from 1st grade to 3rd grade. We'll come back at the end of this video and kind of section out the grade level, section out the time that these happen, because that's another important part of Piecewise. But for now, we're just writing equation. So one thing that we need, I've already pointed out that there is a point on this line that we're going to use, but we do need on this one to talk about slope. So I'm going to zoom in here on section 2 and talk about slope real quick. So as I mentioned before, I'm going to look at this line from left to right. And when I do, I'm going to look at how, in this case, how much it's going down and how much it's going across, or a rise, which in this case is a rise down, and a run, which is a run to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So I'm going 7 down, and when I count down, that's going to be -7 for slope, and then I will count to the right, and that will be 1, 2. So that's +2. We often call this triangle here a slope triangle. And I like thinking about slope this way because it makes sense to me, almost like a hill, right? To talk about the incline of a hill, you have to see how much you're rising and how much you're running. So sometimes we call that, again, the slope triangle. I just made it a little triangle there. But the slope on section 2 is -7 over +2, which is -7 over 2. So let's go back and I'm gonna make section, I'm gonna do the work for number 2 right here. Okay, so I had a slope and the slope is -7 over 2. And I also need a point for this one. And I mentioned this earlier, but the point could be either this point or that point, or really any point along the line. It doesn't matter. It all comes out to be the same equation if you multiplied them out and actually wrote them in slope-intercept form. They would come out to be the same line. So interesting little fact there, but I'm going to use the point 1,4 because that's the one that I called out earlier. All right, so let's go ahead and plug that into our point slope form. So the equation would be y equals -7 over 2 in parentheses x minus, and then my x1, here's the first x that I'm going to use. I'm replacing that x1 with that x, and I'm replacing y1 with that right there, which is a +4. Okay, I'm going to stop there. We could also at some point, it might be fun to come back to, make sure that this multiplied out, and when it does multiply out, we get slope-intercept form and we could double check the y-intercept. But I think I'm going to wait on that because I'd like to keep going on my sections. All right, so let's go ahead and head to section 3. And section 3 has a slope as well. Now I'm on the rise, which is a good thing. So now, like in life terms, now we're talking about moving from 3rd grade to 6th grade. Okay, and from 3rd grade to 6th grade, let's see, I went up 1, 2, 3, 4, 5. And over 1, 2, 3. Okay, so this little slope triangle, if I were to write this as, if I were to write the coordinates here, I went up 5 and I went to the right 3. Both of those are positive directions, so my slope is 5 over 3. Okay, while I'm here too, I'm also going to grab a point. I'm going to pull this point right here. No, I'm going to pull this one. They're both positive. So I'm going to write 6, 2 here for this point. 6, 2, the coordinate, XY coordinates of that point. All right, so I have a slope, I have a point, and I should be good to go. So for section 3, I like to write these out first, just so that when I go back, I remember what I was, all the pieces. So the slope is 5 over 3. And the point that I chose to use, you could use a different point, but the point that I chose to use is 6, 2. All right, so plugging those back into the form, the slope is going to go here, the x value, the y value are going to go here, and then these points, the original x and y, they stay in the equation. So my equation will be y equals 5 over 3 times x minus 6 plus 2. All right. Great, almost done with our equations. Number 4 is pretty easy because that's just a horizontal. So similar to section 1, okay, now I'm talking about from 6th grade to 9th grade. So you'll see why when we go back that it's important to also track the period of time that you're talking about, because I had a different experience between 6th and 9th grade that I did from, let's say, 9th to 12th grade, right? So we will have to go back and fill in that piece, but I just wanted you to kind of hear me talk about that now. So this equation will be y equals, it's a horizontal line, so I'm using just the y equals here, y equals 2. Y equals 2. Okay, and then the last one, let's do this. I'm going to pause the recording. I'm going to do the work for 5, and then let's come and check your work when we're finished with that. Okay, I got the equation y equals 1 times x minus 12 plus 4. So let me show you a couple of things real quick, and also an alternative answer because you might have picked a different point, and I want to show you why they're the same. So when I go up to section 5, I count on my slope here, 3 over 3. And I'm just realizing too, you may not need to draw that slope triangle. That's totally fine. For me, it's a helpful visual, but if you feel like it's crowding your actual timeline, you don't need to use it. An alternative point you could have used for this section, I used 12.4, this one here, but you could have also used the point 9.2. And I'm going to show you what happens if you use that point. Oh, you know what? That's not the point 12.4, is it? Hold up, sorry. Rather than doing this entire video again, I'm going to change that. I just had a moment where I realized that was not right. I'll show you why here in a second, but that's actually the point 12.5. So that means that I need to correct this and I need to correct that. Were you wondering? Just testing you. Okay, so that actually updates my point here. And I did change my slope of 3 over 3 to be 1. Okay, so that might also be one of the differences. So pause that if you need to change any of your work or look into that, okay? If you used the point 9.2, you would have come up with this, x minus 9 plus 2. Now, I want to show you something real quick. This is kind of a bonus feature if you're okay with this. If you don't need the bonus feature, feel free to fast forward, but I want to show you that these two equations, these two, they're actually representative of the same line. So, and one thing I'm going to do, because it's 1 times, right? 1 times this whole thing in parentheses is just that same thing. So I'm going to rewrite, oh good, I was going to rename them 1 and 2, but that's too many numbers. So I'm going to rewrite this one as y equals x minus 12 plus 5. Okay, I just rewrote it without the parentheses because 1 times that expression is just that expression. And then on the same hand, y equals, and if I just take away the 1 times here, that would be x minus 9 plus 2. And if you look at what we have here and we combine like terms, negative 12 plus 5 is negative 7. So y equals x minus 7. And then if I combine like terms here, a negative 9 plus 2, y equals x minus 7 there too. Isn't that cool? So they come up actually with the same exact line. And I can double check on my graph that now I have this. Now here's an example of your slope-intercept form. Slope being 1, right? Slope being 1. Y-intercept being 7. So I'm just going to give myself a visual here and just to make sure, I kind of like sometimes using the slope-intercept form because I can check to see if my my numbers are correct. So I can do this and I'm just going to kind of project this down and just see. So if that line for 5 kept going, negative 4, 5, 6, 7, a little bit, my line's not quite perfect there, but it does, that at least is my confirmation that I have my numbers in the right ballpark, okay? I think I'm gonna stop that video here. We're probably working on about 20 minutes and thanks for hanging in with me on there. In our next video, what we're gonna do is we are gonna add sections to this and so that we can tell which grade levels are connected to which particular sections of lines, okay? Reach out if you have any questions and I will see you in the next video.